3919A Unpossibles, and this is our state interview video. I am Jimmy, I'm in 6th grade, I'm a builder and driver.
I am Thomas, I'm 6th grade, and I'm a builder and driver.
I'm Lucas, I'm in 8th grade, and I'm a builder and programmer.
I'm Aiden, I'm a designer, I'm a builder, and I'm a driver.
I am Sam, and I am in 6th grade. I am a documenter and driver.
I'm Matthew, I'm in 8th grade. I'm a driver, builder, designer, and programmer. This is our primary robot, and this is what we would use for all of our tournaments until we can get this robot to be more efficient in picking up cubes and sky risers.
So for the engineering book, we have lists of components, game strategies, which we use to strategize our moves on the field. I mean, like what we do, and we have programming for the intake and lift and build documentations. So further on, we listed some ways we can build the robots, like some designs. This is one of mine. Pros and cons of our ideas, and etc. So when we move on into the real engineering notebook, we have ways we build the robots through the past and future, like the improvements, like for prototypes and intakes and lifts, and we have etc.
We have a U-shaped base with a tip bar, so that when you lift up the lift, it comes out so it keeps us from falling over. And U-shaped base helps us with stability.
Okay, so for the wheels, we're using mechanical wheels, and so it's able to drift, and also, so it's kind of like hard for the opponents, like to push us to the side.
And for our lift, we used to have a 4-bar lift, which only got us to 24 inches, and it got us to 2nd place in the tournament and excellence award. But the problem was we didn't get much height, and we can only go to the small post. So then we made a 6-bar lift, so now we can go 45 inches and go to the medium post.
Okay, I'll be talking about the intake, and as I forgot to say before, I'm in 8th grade. Okay, so we have a passive intake, which means it requires no motors. We also have these stabilizers so that when we put the cube on, it does not fall off. We have grip to help hold the skyrise and cubes on. The cube would go on the intake like this, and the skyrise would go in the intake like that. The problem is, though, that sometimes it's hard to get the skyrise in, so we're working on a couple of different prototypes too. To fix the skyrise problem, we have this plunger where it goes into the skyrise like this, picks it up from the inside, and then goes down and lifts back up. And then we also have a cube intake that we are working on, where it will go into the cube like this. It also has stabilizers to keep it from tilting from a 90-degree angle too. And it goes up, over, and down like that.
This is our program, and for our drivetrain, we have a holonomic so that it allows us to be able to drift. And in this if loop, if our lift button equals 0, it'll go into the loop, and it'll go run the motors at a constant rate. So instead of our lift falling down from the weight, it'll stay up. And for our autonomous, this is one of our autonomouses. And with our potentiometer, which reads the potential, we can set it to any desired program.
Okay, I'll also be talking about what we do in the community. In our community, we will help other teams by alliancing with them, or will be their partner in a match and basically help them win. We also have made friends along the way, and that is how we help in the community.
The hardest part about building our robot was the lift right here. We had to get all the components correct so that there wouldn't be any clicking noises, so our gears wouldn't get stripped. And we had to make everything so precise that it took hours of work. But with this, we have it so the motors are easily removable, so we can replace them.